Hey, you guys, this is Miss All Day again. We are getting ready to do 6-8 for Algebra 2 General, Charles High School. This lesson is titled Graphing Square Root Functions. Good morning. Hope you guys are doing well. The lesson we're working on today is for Friday, April the 3rd. So I'm going to pull up that worksheet again. This is the worksheet that you need to have printed off. There's a front, there's a back, or a first page and a second page. So go ahead and get this out, or if you're using graph paper and you're using your spiral composition notebook, go ahead and get that out because you're going to have to do some graphing. All right, so we're going to get started. All right, describe the transformations from the parent graph. All right, let's look at this parent graph for a minute. So what I want you to do up at the top of this page is I want you to write this standard form of a square root function. It's going to look really familiar, really familiar because it looks kind of like the parabola. Now I'm going to write in blue what the parabola looked like. Don't write this part. F of x equals a parentheses x minus h squared plus k. All right, remember, that was the parabola. All right, now I want to show you using black, but it's kind of the same. It's just this one in blue is a parabola, and the one that we're doing today is going to be a square root function. So see the a on the outside in today's function is basically doing the same thing as the a on the outside in a parabola. It's either going to compress the function or it's going to stretch the function. All right, now underneath the radical, that minus h, it's a liar, okay? The negative is already in the formula. It's already in the square root function form. Look down at the parabola. Remember how the minus h, that was a liar. The parentheses are a liar. But that's really the opposite of what you see. That tells you underneath the radical and inside the parentheses, that tells you whether you're going left or right. So if it's like this, if it says, and I'm going to do a parabola first. If it says, we'll say negative x minus 2 squared plus k. That minus 2 is the opposite of what you think. It's not go to left. It means go to right. All right, let's look at the k part. All right, in today's square root function, the k is on the outside of the radical. It is not included underneath the radical. So that's going to tell you whether to go up or down. Just like if you look below with the parabola, that k tells you to go up or down. All right, so let me erase this because I just wanted to show you how similar this is going to be. That if you remember how to graph parabolas, that being able to graph a square root function is going to be very, very similar. You're just applying kind of the same concept to a new one. All right, so describe the transformation from the parent graph. So f of x equals the square root of x is actually the parent graph. So we're going to describe the transformation first. So I always go look inside first. You don't have to. Now remember, underneath that radical, it's a liar. So that's telling you to either go left or to go right. Now you would think it will be right since it's a plus 5, but it's the opposite of what you think. So really it's a left. So we are going to say that the parent graph f of x equals the square root of x is shifted left 5, and now I'm going to look at the part that takes the place of k. For this one, it's plus 4. That tells you whether or not you're going to go up or down. So that's going to be and 4 units up. So let's read this. F of x equal the square root of x is shifted left 5 and up 4 units. I want to write it like that instead of 4 units up. And up 4 units. All right, so we described the transformation. There's nothing else we need to do in that problem to describe the transformation. I want to make sure you understand, though, why underneath the radical that ended up being left. So if you had your form x minus h plus k, and you inserted in here the left 5, that's a minus 5, x minus a minus 5, that makes it x plus 5. That's why it's the opposite of what you think. Okay? All right, next thing we're going to do is we're going to do a table so we can graph. All right, so I'm going to do a table right here. Before I can even start the table, let me pull up a different color. I'm going to pull up green. You look underneath the radical. You take that x plus 5, just like we were doing yesterday, and that x plus 5 has to be greater than or equal to 0. If it is not greater than or equal to 0, it will end up being a negative number underneath the radical, which means it's going to end up being an imaginary number. And we are not graphing imaginary numbers. We're graphing functions. All right, so you take what's underneath the radical and you say that has to be greater than or equal to 0. So you're going to subtract 5 from both sides. X is greater than or equal to negative 5. That tells you where you're starting. That also tells you that's your domain. And we'll write that down below in a minute. All right, what you're going to do now is you're going to take that negative 5 and you're going to plug it in to your example problem. So y equals the square root of negative 5 plus 5 plus 4. All right, negative 5 plus 5 is 0. And the square root of 0 is 0. So y is 4. All right, that's my first point. Now, how do I figure out how to do my second point? What you want to do next is go back down here. X has to be greater than or equal to negative 5. So the next number that's greater than negative 5 is going to be negative 4. All right, so I'm going to write that in my table. All right, I'm going to go back up to my problem and put negative 4 where x is. So negative 4 plus 5 is 1. So you have the square root of 1 plus 4 now. The square root of 1 is 1, and 1 plus 4 is 5. All right, so I'm going to put that in my chart. All right, just like yesterday, we need to figure out how we can make whatever ends up underneath the radical being a perfect square so it's easy to do. So let's think about this for a minute. X plus 5, and then the plus 4 is on the outside of the radical. The next number of x that is greater than or equal to negative 5 is going to be negative 3. But if I put a negative 3 underneath the radical, I'm going to get the square root of 2. And I don't really want to work with radicals that aren't perfect squares. So I'm not going to use negative 3. If I put underneath the radical a negative 2, that's going to be the square root of 3. And the square root of 3 is like 1.7 something. But I don't want to graph that. So I'm looking for a whole number. So I tried negative 2. I had already tried negative 3. Now I'm going to try negative 1 and see if it works. If I put a negative 1 underneath the radical, it's going to be the square root of 4 plus 4. Oh, that's good. The square root of 4 is 2, and 2 plus 4 is 6. All right, so I put a negative 1 in the equation, and I got 6. All right, so that worked out good. So negative 1 worked. All right, another number that is greater than or equal to negative 5. The next number would be 0. If I plug a 0 in here, that's going to be the square root of 5 plus 4. No, I don't want to do that. So we're not going to use 0. I want to try to have 5 points if you wonder why I keep going. All right, so let's do 1. 1 plus 5 is 6. The square root of 6, no, don't want to do that. I'm not going to do that. All right, let's try 2. 2 plus 5 is 7. Square root of 7, nope, don't want to do that. All right, let's try 3. 3 plus 5 is 8. The square root of 8, nope, don't want to do that. So I'm not going to do that one. Nope. So let's try 4. 4 plus 5, that's going to work. 4 plus 5 is 9. Square root of 9 is 3. And 3 plus 4 is 7. So I had plugged in a 4. All right, let's do at least one more. So now that you're kind of figuring out what I'm doing, I'm looking that what's underneath the radical needs to be a perfect square. So I want what's underneath the radical to be either a 0, a 1, a 4, a 9. I've done that so far. The next one is I want it to be a 16. So let's go up here where x is. And let me do this in neon so you know where I'm at. What does x have to be? What number added to 5 will give you 16? And you're like, well, that's easy. 11. All right, then that's what we're going to put. We're going to put 11 in our table. 11 plus 5 is 16. The square root of 16 plus 4 is 4 plus 4, which is 8. So I have 5 points now. I wanted to try to get 5 because it makes a better picture. It makes you know for sure what your picture looks like. All right, so we described the transformation first. Then we made a table of values, and we're going to use that table to graph each function. All right, so I'm going to shrink this a little bit just so I can fit my points and my graph on the same page. So remember, if I'm going too fast or anything, just pause it. All right, so let's graph these points. -5, 4. -4, 5. -1, 6. 4, 7. And we can do this one. 11, 8. Now, this -5, 4 is always your starting point. So if you notice, this does not look like what we were graphing yesterday. Do not write what I'm fixing to write. Yesterday, we were graphing a sideways parabola, and it did not pass the vertical line test. It wasn't a function. So why is what we graphed yesterday different, or the day before I think it was, different than what we graphed today? Here is the key. Let me show you how it's different. When we were graphing the other day, we were doing plus or minus radical something. It had a plus or minus in it, which means once you did these points, you reflected them and did these points. That's what that plus or minus did. Today, with our radicals, because we're graphing square root functions, not just square roots, there is not a plus or minus in front. So we can't put one there. So when you graph square root functions, it's going to always look like this. The top of a parabola, the bottom of a parabola, or it could go this way, or it could go this way. So that's what it's going to look like. It's going to look like the half of a parabola, but it's going to be sideways. All right, so that's the square root function. Then it says to state the domain and range. All right, I had already told you that this right here was the domain. So x is greater than or equal to -5. All right, the range is going to be really easy. Sometimes I like to erase stuff just so you know kind of where I'm at. So you're not trying to look and see where in the world is this pin at this time. All right, so I'm going to do this in pink. Right here in your table, you see the -5 and the 4? We said x is greater than or equal to -5. That's what we put for our domain. Your domain, y, is going to have a 4 in it. It's always your x and your y, your domain and your range is always going to start out with whatever these 2 points are you started out with. So the way you have to figure out what you're going to do is look at these numbers that I'm circling in pink. Are they getting bigger or are they getting smaller? They are getting bigger. So y is going to be greater than or equal to 4. So your range is y is greater than or equal to 4. All right. All right, we're going to go to our next problem. Y equals negative radical x minus 6. And we're going to start by describing the transformation first. Now, you don't have to start on the inside if you don't want to, especially when you see that negative on the outside. That negative on the outside means it's going to be reflected. So it's going to be upside down to what we just did. So we're going to say, just another way of writing the transformation, we're going to say the parent graph, instead of writing out literally the parent graph, we're going to say the parent graph is reflected over the x-axis. All right, so we took care of that one. Now there's nothing going on underneath the radical. There's not like an x minus an h or x plus an h. There's nothing going on there. So it is not shifting left or right. Okay, so we do see a -6 on the outside. Now remember, that tells you whether you're going up or down. And since it's a negative, you're going down. So the parent graph is reflected over the x-axis and vertically shifted 6 units down, or down 6 units, however you want to say it. So you notice I did a little bit different this time. Before, I had said f of x equals the square root of x. That was another way of saying the parent graph. That's the parent graph I'm talking about right here. All right, next thing we're going to do is we're going to make a table. So x and y, we're going to try to do 5. That's the magic number, 5 ordered pairs. All right, so the first thing you want to do is you want to go look underneath the radical. That's where you go first. So let's do this to help you remember. We're going to look under the radical, okay? So whatever's there, pull it out and say, okay, that has to be greater than or equal to 0. I didn't have to solve it like I did before. That's my domain. Let's go ahead and put that where our domain is. Our domain is x is greater than or equal to 0. Okay, so that's where we're going to start. We're going to plug 0 in. All right, so y equals negative radical 0 minus 6. Well, we know the square root of 0 is 0, and there's no such thing as a negative 0. So this is really 0 minus 6, which is negative 6. All right, so let's write that in our table. Now, that's going to be our range. So go ahead and go down to the bottom and put y, and then put negative 6. Now we're going to figure out in a minute, are we going to do greater than or equal to? We're going to do less than or equal to. Now I know we're going to do less than or equal to, but I'm going to show you why we're going to do less than or equal to. All right, go back to your domain. And we said that x has to be greater than or equal to 0. So I'm going to use 1. All right, so y equals negative radical 1 minus 6. The square root of 1 is 1, but you have to put that negative in front. So negative 1 minus 6. All right, that's negative 7. All right, look at those numbers. Are they getting smaller or bigger? They're getting smaller. So that's why we're going to go down to the bottom where it says range. Y is less than or equal to negative 6. Okay, because they're getting smaller, so it's less than. It makes sense. All right, let's go plug in another one. Let's see, a number that's greater than 0. We already did 1. We could do 2, but think about it. If I put a 2 here, the square root of 2 is like 1 point something, and I really don't want to work with decimals. What would happen if I put a 3? Nope, that's like 1.7. I don't want to do that. We're going to put a 4. So y equals negative the square root of 4 minus 6. Negative the square root of 4 is 2 minus 6. That's going to be negative 8. So I put 4 in, and I got a negative 8 out. We're still going to do 5 points, even though we're going to end up falling off the graph a little bit. All right, so, excuse me, x is greater than or equal to 0. So we're at 4. If I put a 5 in there, that's not a perfect square. A 6 isn't, a 7 isn't, an 8 isn't, but a 9 is. So I'm going to do a 9. So y equals negative radical 9 minus 6. So that's negative square root of 9 is 3 minus 6. It's negative 9. All right, we're going to do one more. My next perfect square is 16. This one I won't be graphing, but I am going to put it in my table. So y equals negative radical 16 minus 6. The square root of 16 is 4, so negative 4 minus 6 is negative 10. All right, so we described our function. We made a table. Now we're going to use that table and we're going to graph it. All right, so let me scroll up a little bit. Graph with me, please. So 0, negative 6, that's my starting point. 1, negative 7, I'm going down. 4, negative 8. 9, negative 9. Okay, you can tell which way it went. It's kind of like it's scooping. All right, let's kind of compare just for a minute. I'll do this in yellow. The one we just did was like over the top, okay? Kind of like rainbow looking, so to speak, we'll say, okay? The one that we just got finished doing is going under. It's kind of like scooping up like you would a shovel, okay? All right, I want you to notice something about the problems. The first one we did not have a negative in front, so it was over the top, okay? And both of our signs for our domain and range were greater than or equal to. All right, let's look at the one we just did. The one we just did had a negative out in front. That meant it was reflected. Okay, it looked like this, so to speak. And it was the range that ended up being less than. The domain stayed greater than. So it was reflected. So when it is reflected, it is your range that's going to be less than or equal to. So if you look at a problem like this one here, and you see that right there, you're like, okay, well, in a minute when I write my range, I need to make sure that I'm doing less than or equal to, or either I'm not doing it correctly. So that's another way you could tell whether it's greater than or equal to or less than or equal to. All right, next page, you guys. 2 more problems, and then you have a worksheet for homework for this, and it's a new worksheet. All right, so we are going to describe. I'm going to start with what's on the in front of the radical on the outside. So I'm going to say the square root of x, because that's the parent function, is shifted. No, we don't want to do shifted. I'm sorry, we're going to do compressed. I didn't mean to say shifted. Is compressed by a factor of 1/2. All right, so remember when that whatever's in front of the radical, it's called a, okay? If the absolute value of a is less than or equal to 1, it's compressed. If the absolute value of a is greater than or equal to 1, it's stretched. Okay, so it's being compressed because 1/2 is greater than 1. All right, so the square root of x is compressed by a factor of 1/2 and shifted. So we know this is the opposite, so it's not going left 2, it's going right 2. And shifted right 2 units. All right, the table. So we're going to take what's underneath the radical, x minus 2, and we're going to say it's greater than or equal to 0. We're going to add 2 to both sides. X is greater than or equal to 2. That's the number we're starting with. And we could go ahead and write x is greater than or equal to 2 down at the bottom of your page where it says domain. X is greater than or equal to 2. Now, we could go ahead and put y is greater than or equal to something because the number that's in front of the radical is positive. So that means our x and our y, our domain and range, are both going to be greater than or equal to. So that's kind of good to know. All right, so we're going to go ahead and plug in and see what our y is greater than or equal to is going to be. That's our range. So I'm going to go to red. I am going to plug it into the original problem. So y equals 1/2 the square root of 2 minus 2. Now 2 minus 2 is 0, and the square root of 0 is 0. And anything multiplied by 0 is going to be 0. So I can put my 0 in my table. can put it over here to the right to show that y is greater than or equal to 0, and then go to the bottom of the page, my range, y is greater than or equal to 0. All right, so now we're going to go back to the y is greater than or equal to 2. That's the one that tells us what to put in our table. So you're thinking of a number that is greater than or equal to 2. So let's try 3. All right, so we're going to say y equals 1/2 times the square root of 3 minus 2. Well, 3 minus 2 is 1, and the square root of 1 is 1, and 1/2 of 1 is 1/2. Now, that is a point. It's not a point I'm going to graph because it's kind of hard to graph. So I'm going to go ahead and go to the next number. What's the number that's greater than or equal to 2? 4. All right, so we're going to try 4. So y equals 1/2 the square root of 4 minus 2. 4 minus 2 is 2. And if I multiply the square root of 2 times 1/2, that's not going to be very pretty. So I'm not going to use 4. Okay, and let's go ahead and look up here and see what would be next. 5. 5 minus 2 is going to give me a 3, so I don't want a 5. 6 minus 2 is going to give me a 4. That's what I want to do next. I want to do 6. I'm going to erase my 4. My next number I do is going to be 6, because I want it to be where I could graph very easily. All right, now I'm going to show my work over here, but I'm going to erase it. So we have y equals 1/2 the square root of 6 minus 2. All right, 6 minus 2 is 4. The square root of 4 is 2. So half of 2 is 1. All right, that's a nice point. Let's see if I can get another one, a nice point. So let's see, I have to think of a number now that's greater than or equal to 2, but I've already gotten all the way up to 6. 7, if I plugged it in, 7 minus 2 is 5. I'm not going to use 7. 8, if I plugged it in, 8 minus 2 is 6. I'm not going to use 6. 6 is not a perfect square. 9 minus 2 is 7. 10 minus 2, 8. 11 minus 2, that's it. That's the one I want to use, 11. All right, so I'm going to put 11 in my table. All right, let me erase a little bit so you kind of know where I'm at, and you're not trying to figure out, okay, where is she writing at next? All right, so we're going to plug in 11 now, and we're going to see what point that is. And we might stop at 11, even though I normally do 5 points. So we're going to say y equals 1/2 the square root of 11 minus 2. 11 minus 2 is 9. The square root of 9 is 3. Half of 3 is 1.5. That's not really a very good one. So let's go back up here. How can I make that a 16? What number take away 2 is 16? 18, right? Let's go ahead and do a third point. All right, y equals 1/2 times the square root of 18 minus 2 equals 1/2 times the square root of 16. The square root of 16 is 4, so half of 4 is 2. That's a pretty good point. All right, let's go graph those. So we have 2, 0. That's our starting point. We have 3, 1/2. I'm going to go ahead and do it because I don't have very many points. And then we have 6, 1. Look how tight that one is. Goodness. That's why it's called compressed. All right, let's go to our next problem. All right, I paused the video so I could erase and so it wouldn't look so cluttered. All right, so now, first step, new problem, last problem. What we're going to do is we're going to describe it first. So I'm going to start with the negative. So I'm going to say the square root of x is reflected. That negative always means reflected over the x-axis. In ATM, you'll probably reflect over the y, but in Algebra 2 General, we only reflect over the x. Then I'm going to put a comma, and I'm going to take care of the 2, and that means it's stretched by a factor of 2. Now I'm going to go on the inside. That's a liar, so it's not adding 8 really. it looks like it would be 8 to the right, but it is not. It's the opposite of what you think. So it's going to be 8 to the left. So we're going to say shifted left 8, and we're going to go to the outside. That tells me up or down. Since it's negative, it's down, and down 1 unit. Okay, so let's look at that again. Transformation, describing it, is the square root of x is reflected over the x-axis, stretched by a factor of 2, shifted left 8 and down 1 unit. All right, so next we're going to do a table. Remember, when you're getting ready to do the table, you are going to go underneath the radical and rewrite that. So you're going to rewrite the x plus 8. All right, so x plus 8, you're going to say it has to be greater than or equal to 0, and you're going to solve it. So when you subtract 8 from both sides, you're going to get that x is greater than or equal to negative 8. All right, so that's going to be your first point. That's also your domain. Let's go write that for your domain at the bottom of the page. X is greater than or equal to negative 8. Now we could go ahead and put y is less than or equal to, because there's a negative out in front. So I know my y is going to be less than. All right, let's go see what our range starts with. We already saw that our domain starts with negative 8 and it gets bigger. Let's see what happens with our range. So I'm going to plug in that negative 8 into this problem. So negative 2, the square root of negative 8 plus 8 minus 1. All right, the negative 8 plus 8 ends up being a 0. Now this is now a 0 because the square root of 0 is 0. Now negative 2 times 0 is 0, and 0 minus 1 is negative 1. All right, so our y is going to be less than or equal to negative 1. All right, scroll down to the bottom. We have y is less than or equal to negative 1. We have our range. All right, so now we're going to go back to what our domain is, negative 8. Let me put a negative 1 in my table, and let's think of a number that is greater than negative 8. All right, so let's start with negative 7. Let's go plug that one in. Erase my work. I'm going to plug it in right up here where the problem's at so you can see me plugging it in. This is a part that you might want to do in scratch paper because there's just not enough room. All right, so y equals negative 2, the square root of negative 7 plus 8 minus 1. All right, negative 2 times the square root of 1, put that in parentheses. Negative 2 times 1 minus 1. Negative 2 times 1 is negative 2, and negative 2 minus 1 is negative 3. All right, so we plugged in a negative 7, and we got a negative 3. All right, let's see what number would work best next. It's got to be greater than or equal to. If I plug in a negative 6 here, I'm going to get a 2. 2 is not a perfect square. I want it to be a 4. So negative 5 makes it a 3. Negative 4. There we go. That's my next one. I'm going to plug in a negative 4. All right, so we're going to do, I'll do this in black so you know where I'm at. Y equals negative 2, the square root of negative 4 plus 8 plus, minus 1. My bad. So negative 2 times the square root of 4. The square root of 4 is 2. Negative 2 times 2 is negative 4. And negative 4 minus 1 is negative 5. Negative 4, 5. All right, let's see now what would be another number that is greater than or equal to negative 8 that we could plug in. So the last one we just plugged in was negative 4. I don't want to plug in a negative 3, makes it 5. I don't want to plug in a negative 2, that makes it 6. I don't want to plug in a negative 1 because that makes it 7. I don't want to plug in a 0 because that makes it 8. My next number I want it to be is 9. So I want it to be a 1. I'm going to plug in a 1. All right, so we have y equals negative 2, the square root of 1 plus 8 minus 1. So we know that 1 plus 8 is 9, and we know that the square root of 9 is 3. So you have negative 6 minus 1, which is negative 7. All right, we're going to do one more. What does x have to be for that to be a 16? Well, it has to be 8. All right, so we're going to do -2, the square root of 8 plus 8 minus 1. We know that 8 plus 8 is 16, and we know that the square root of 16 is 4. So we're going to do -2 times 4 minus 1. -2 times 4 is -8, and -8 minus 1 is -9. So we ended up plugging in the 8, and we got a -9. Okay, I have my 5 points that I wanted. All right, so let's graph them. So -8, -1, -7, -3, -4, -5, 1, 7, and 8, -9. Now there's a couple of things you can tell about this picture. It's half a parabola, that's one. It's reflected because it's upside down from the previous one. And you can tell that it got stretched because it got fatter. All right, now let's see if there's anything else I missed. All right, so we are finished with lesson 6-8. I'm going to leave this page, and I'm going to show you your homework for tonight. Today is Friday, April the 3rd. We just got finished graphing radical functions, and you're going to have a new handout that you're going to copy. Either you're going to download it and copy it, or you can just write your answers in your spiral composition notebook and just label it 6.8 handout. Now, after you do the 6.8 handout, remember you've got to do that mandatory upload. That's where your grades come from. So you're going to also upload 6.8 standardized test prep worksheet. You're going to do it in pen, follow the instructions I already gave you, and upload it to Focus. All right, there's something else I want to show you. See if I can open this up over here. I want to show you a couple of other things. This is what the worksheet's going to look like that you download. It looks very similar to one that we've done before, but all the numbers have been changed. So you're practicing it again if you were in my class or Mr. Kenyon's class. All right, this is what your 6-6 upload should have looked like. So if you didn't upload this, this is what it should have looked like. And you would have done numbers 1 through 5. And then at the bottom, you would have put, I watched the videos, took notes, and did my homework. And then you're going to sign your name if you did that. Okay? And then you upload that. Now remember, you're writing in pen. You are circling whatever your answer is in pen. Or if you'd rather put it out here, I'm not looking at it, so I don't know if that's really the answer or not. And then on your scratch paper, you're writing that in pen. But remember, I need your name in pen. I need your class period. So if you're in my 3rd period or my 6th period, I need the date. Okay, so all that stuff. But this is the standardized test prep that you should have already downloaded and uploaded into Focus. All right, this is the one you should have done yesterday. Okay, so you would have done 1 through 4, and then at the bottom, you would write that statement again. And then this is the one that you're going to do after you do tonight's homework. This is the one that you'll do for the upload. You see it has 4 questions. Okay. All right, so basically over the weekend, if you got behind in your homework or anything, just catch up, get those worksheets uploaded by Sunday midnight. All right, and then I'll see you on Monday. Thanks, you guys. Bye.